Our goal for today is to know how to multiply terms that have exponents. Okay, and I made up this example on the left, actually two examples, just so you can see the idea behind it before we get into it. Okay, so if I have x to the third, okay, what that means, it means x times x times x if I expand it. And if I have x to the fifth, that means 1, 2, 3, 4, 5. X times itself 5 times. Remember, this x is called the base. That's what I'm multiplying. The exponent tells me how many times I'm multiplying it. Well, now look what I have. I have x times itself 1, 2, 3, 4, 5, 6, 7, 8 times. So this is really x to the 8th. Okay, so what's the idea? What's the shortcut so that you do not have to keep writing this out? Right? You don't want to have to expand it all the time. You just want to get right to the answer. Well, if I have x to the third, I have x multiplied by itself 3 times. X to the fifth is x multiplied by itself 5 times. So what am I doing with those two exponents to get my final answer? I have to add up those exponents. Okay, so when you have the same base, okay, actually let's make it more specific. If you're multiplying with the same base, all you have to do is add the exponents. Okay, let's look at the other example that I made up. Again, you don't have this one, but we're just seeing the idea behind what you're going to be doing today. Okay, so if I expand this one, if I have y to the third, that's y times y times y. Times, okay, these parentheses also mean times, z to the fifth. So I'm going to have z multiplied by itself 5 times. Well, now if I try to simplify this, now I have different variables, different letters. So I can group the y's together. Okay, I have y times itself 3 times, so that's y to the third. Again, not the same as 3y. And I have z to the fifth, not the same as 5z. Oh, that was pointless. It's the exact same thing that we started with. Okay, so if you have different bases, okay, here you had a y and a z, okay, then you can't multiply them. You can't simplify the expression at all. Okay, so we're only looking at like bases, and if we're multiplying with like bases, then we can add the exponents. Okay, so we're going to look at the even ones together. Okay, so let's look at number 2. Okay, so number 2 I have 4. Now, if there's no exponent written, it's really 4 to the first power. I only have 1 4. So I have 4 to the first times 4 to the second. These have the same base. Okay, so if I have the same base, I can add these exponents. Okay, if I'm doing a multiplication problem with the same base, I add the exponents. Okay, so I'm going to keep the base the same. 1 plus 2 would be 3. Again, we can write this out in the expanded form. That's 4 to the first power. Here's 4 to the second power. Together, I have 4 to the third power. Okay, these all have like bases. That's good. They're all 2's to start. And my exponents are 1, 2, and a 2. Remember, if there's no exponent written, there's a 1 there, not a 0. So 2, I'm going to keep that base, add up these exponents, 1 plus 2 plus 2, that is 5. So it'll be 2 to the 5th power. Okay, for number 6. Number 6, now we have numbers in front of our variables. They're called coefficients. Okay, so I'm going to multiply those numbers like I would multiply regular numbers. Okay, 6 times 5, you knew since elementary school. That's not going to change. 6 times 5 is 30. We're worried about the variables and the exponents. So I have r to the first, and I have r to the second. So 1 plus 2, that would be r to the third power. Okay, 6k squared times k. Okay, now they're not going to write in all these ones, but there's a coefficient of 1. That's 1k. And there's an exponent of 1. Okay, so for my coefficients, 6 times 1 is 6. K, and I'm going to add up these exponents. 2 plus 1 is 3. K to the third power. Okay, number 10. I'm going to put a 1 here. Coefficients, 4 times 3 is 12. X, 2 plus 1 is 3. 12x to the third. Okay, go ahead and try number 12. Okay, the numbers when you multiply, 36. And the x should be raised to the fourth power. Okay, let's look at some examples with more than one variable. Okay, so here I have x's and y's. Okay, so I'll do the numbers first. 9 times 9 is 81. Then I have x to the first times x to the fifth. Okay, so I'm just looking at these like bases. And I can multiply those because they're both x's. So for my x's, it's going to be x to the sixth. The y's also, those have the same base, so I can multiply those. Y squared times y squared would be y to the fourth. Okay, so if you have more than one variable, you're trying to pick out the like bases. Okay, let's handle the numbers first. 6 times 6 is 36. The x squared, I'm going to multiply it by the x to the third. They have the same base. And I'm going to add those exponents. 2 plus 3 is 5. The y doesn't have anything to multiply it by, so I'm just going to carry it down. Y to the fourth. Okay, let's look at two more. Okay, there are all ones as my coefficient, as these exponents. And so for my coefficients, the numbers in front, 1 times 4 is 4. For the u's, I have u to the first times u to the first. Add those exponents just to get u to the second. And for the v, I have v to the first, v to the fifth. 1 plus 5, that should be v to the sixth. Okay, and here's one more that we'll do together. Coefficients first. 3 times 7 is 21. U to the fourth times u to the second would be u to the sixth. V to the fifth times v to the third would be v to the eighth. Okay, so just as a review, okay, when you're multiplying, you can only do the like bases. Okay, like the v's were the same base, and then you add the exponents. If there's no exponent, okay, think of it as an exponent of 1. All right, here are some for you to try out. All right, pause the video and see if you can do 13, 15, 17, 19, and 21 as a little bit of a challenge. And for number 13, 560, u to the fourth, v to the 11th. Okay, now you may have written these in a different order. Okay, I usually try to write alphabetical order. Maybe you did the v to the 11th first and the u to the fourth first. Okay, you can switch those. It's called a commutative property. Okay, you can write it in a different order when you're doing a multiplication problem. Okay, number 15. 48 m to the fifth, n to the sixth. Number 17. 63 u to the third v to the eighth. 19. 80 x to the sixth y to the sixth. And then 21 just has a little bit of a challenge. Okay, we're going to rewrite this. Okay, we have this term to the second power. Okay, so what that means, it's that term multiplied by itself. Okay, the part in parentheses is what I'm multiplying, and then the exponent tells me how many times. Okay, so this is really an exponent problem, but I turned it into a multiplication problem. Now I can do 2 times 2 is 4, and I can add my exponents now. X to the second times x to the second is x to the fourth. Okay, so when I had an exponent, I rewrote it as a multiplication problem. Okay. Again, you will see a trick that takes you here right to here later on. Okay, but I just wanted to give you this one as a preview.